Right now, beneath your feet, there's an ocean, not a metaphorical ocean, a real ocean of water, hidden underground, stretching for miles in every direction. In fact, there's more fresh water trapped beneath the Earth's surface than in all the lakes, rivers, and glaciers combined. But here's what will blow your mind. Scientists still don't fully understand where all this water came from, and some of the answers they're finding suggest that groundwater might be connected to something that changes everything we know about Earth's history. Over the next 5 minutes, I'm going to reveal where groundwater actually comes from, and one theory that suggests it might be older than the planet itself. If you've ever wondered why wells work, or why some places have abundant water while others are deserts, the answer is groundwater. But most people think groundwater is just rainwater that's soaked into the ground. Simple, obvious, except it's not. That's the official explanation. And it's only part of the story. I've spent years studying hydrology, geology, and some seriously controversial research. And what I found is that the origin of groundwater is far stranger than anyone tells you. In the next 5 minutes, I'm going to show you 5 theories about where groundwater comes from. And the last one will make you question the fundamental nature of our planet. This is going to get weird. Let's start with what they teach in school. When it rains, water falls from the sky. Some of that water runs off into rivers and lakes. Some evaporates back into the atmosphere. But some, approximately 30% of rainfall, soaks into the ground. This water percolates down through layers of soil and porous rock, eventually reaching the water table, the underground level where all the spaces between rock particles are filled with water. This water then flows slowly through underground aquifers, moving at a rate of just a few feet per year. It's a simple cycle. Rain falls, water infiltrates, groundwater is created. This process is real. It's been measured. It's documented. But here's the problem. It doesn't explain where most groundwater came from, because if you calculate how much rain has fallen on Earth over the past 10,000 years and compare it to how much groundwater exists underground, the numbers don't match. There's too much water down there. Way too much. By the way, researching how easily groundwater can be contaminated, it made me a little paranoid about my own tap water. So I actually bought a simple home test kit just to see what exactly I'm drinking every day. It tests for lead, bacteria, and hardness in seconds. It was honestly kind of shocking to see the results. If you're curious about what's really in your glass, I've linked the exact kit I used in the description below. It's a cheap science experiment you can do in your kitchen. Okay, so if rainfall doesn't fully explain groundwater, where did the extra water come from? One theory, the oceans. Millions of years ago, when the continents were in different positions and ocean levels were higher, seawater covered areas that are now dry land. Over millions of years, that seawater was trapped underground, sealed beneath layers of rock and clay. But here's the thing, seawater is salty, and most groundwater is fresh. So how did the salt get removed? The answer is complex, involving chemical reactions, mineral exchanges, and desalination processes that took millions of years. But evidence supports this theory. In some regions, scientists have found pockets of ancient seawater trapped hundreds of meters below the surface, complete with fossilized marine organisms. It's literally a time capsule of prehistoric oceans. The problem is, this theory only explains groundwater in specific regions. It doesn't explain where all the fresh groundwater in the world's deep aquifers came from. Here's where it gets interesting. Water isn't just sitting in rocks underground. It's chemically bound to minerals. Minerals like feldspar, mica, and silicates contain hydrogen and oxygen atoms bonded together in crystalline structures. When these minerals are buried deep in the earth and exposed to extreme heat and pressure, they can release the water trapped within them. This is called mineral dehydration. It happens at depths of several kilometers, where temperatures exceed 200 degrees Celsius. The released water, which has been locked inside rock for billions of years, percolates upward and becomes groundwater. Some geologists believe this process explains a significant portion of Earth's groundwater. The water isn't from rain or ancient oceans. It's being continuously generated by chemical reactions happening deep underground. Essentially, the planet is producing water. But if the planet is continuously making water, then the amount of groundwater on Earth should be increasing over time, which means our aquifers should be getting fuller, not emptier. But they're getting emptier. We're pumping groundwater faster than it's being replenished. So where is the replenishment supposed to come from if the chemical release is slow? That's when scientists discovered something that shouldn't be possible. In the 1990s, geologists made a shocking discovery using seismic imaging. They found evidence of enormous amounts of water trapped deep within the Earth's mantle, the layer beneath the crust. We're talking about water equivalent to multiple ocean volumes, locked inside rock at depths of 400 to 700 kilometers. But here's where it gets mind-blowing. This water isn't stationary. It's being transported upward by convection currents in the mantle. Basically, the Earth's interior is cycling water the same way the surface cycles water, except at a planetary scale, over millions of years. This water is being pushed upward toward the crust, where it can be released through volcanic activity, hydrothermal vents, and mineral dehydration. So groundwater isn't just being recycled from the surface, it's being continuously supplied from Earth's deep interior. This theory explains why some remote areas with virtually no rainfall still have abundant groundwater. The water is coming from the planet itself. But the question remains, where did that deep mantle water come from originally? And the answer to that question leads to something absolutely wild. Okay, this is the one that sounds like science fiction. Some researchers, including geochemist Robert Ballard and astronomer Wickramasinghe, have proposed a controversial theory. Maybe Earth's water didn't originate on Earth. Maybe it came from space. The theory is called panspermia, and it suggests that water molecules, simple organic compounds, and even microbes were delivered to Earth from comets and meteorites billions of years ago. Here's the evidence. Comets are essentially flying mountains of ice and rock. When they collide with planets, they deliver massive amounts of water. Scientists estimate that early Earth was bombarded by billions of comets over millions of years. Each impact delivered water, ice from the outer solar system. Over time, this water accumulated. Some stayed on the surface, forming oceans. Some was trapped deep within the planet, becoming part of the mantle. Now here's where it gets controversial. Some researchers believe that not all Earth's water came from the beginning of the planet's formation. They believe water is still being delivered. Comets still hit Earth. Meteorites still rain down from space. If you calculate the total water being delivered from space annually and project it backward over billions of years, it matches the total amount of water on and in Earth. But mainstream geology doesn't accept this fully. Most scientists believe Earth was already formed with its water content, delivered during the planet's formation 4.5 billion years ago. However, some fringe researchers have noticed something strange. In certain deep boreholes, scientists have found fresh water at depths where it shouldn't exist according to conventional infiltration models. The water appears to be coming from beneath the crust, potentially from meteorite impacts or cosmic sources that broke through from below. It's called the primordial water hypothesis. And if it's true, then groundwater isn't just recycled rainwater or ancient seawater. It's literally water from the cosmos, water that arrived from other parts of the solar system billions of years ago. So where does groundwater come from? The answer is all of the above. Some comes from rainfall. Some comes from ancient oceans. Some is released from minerals deep in the earth. Some is being transported from Earth's mantle through convection cycles. And according to some researchers, some might literally be water from space, delivered by comets and meteorites over billions of years. The truth is, we still don't fully understand the complete water cycle of our planet. Every time scientists think they figured it out, new discoveries force them to revise the model. What we do know is this: there's far more water beneath your feet than anyone realizes, and it's connected to processes operating at scales we're only beginning to comprehend. The next time you drink a glass of water, understand that water might have come from a comet that crossed the solar system. It might be locked in rock at the bottom of the ocean. It might be cycling up from the Earth's mantle right now. Water is older than we thought, stranger than we understood, and far more precious than we give it credit for. Now, speaking of detecting invisible things beneath the surface, you know what else we can detect that we can't see? That airplane flying 35,000 feet above you right now. A system knows exactly where it is, down to the meter. How? The same echo principle. But instead of sound waves, it's radio waves traveling at the speed of light. I made an entire video breaking down exactly how radar works. And if this video blew your mind, that one will too. It's the same fascinating physics, just applied in a completely different way. Check it out right here. And if you want more videos exploring the hidden mysteries of our planet, the things beneath the surface, literally and figuratively, hit that subscribe button, because the Earth has more secrets than we've discovered. Until next time, stay curious. And remember, whether it's water underground or planes in the sky, we're getting really good at seeing the invisible.